Alright guys, so in the last video we left off at section 3.1.3 activity 1, so I'm going to do activity 2 now, and this is an interesting one. Alright, we actually use derivative instead of just computing them. We're going to use it to find something useful. Anyways, find the point on the curve y equals to 3x squared minus 2 at which the gradient is 0.5, right? What does this mean? We have a curve, right? Let me draw my x and y axis. I don't know where it is exactly, but I'm just guessing that, I don't know, looks something like this. It's a parabola, right? I don't care where it is. Anyways, find the point on the curve such that the gradient is half. Now, what do you mean by gradient? Gradient is the slope. Gradient is the derivative. So, we know that this curve y is equal to 3x squared minus 2, right? And then we want to find a point on the curve, like, I don't know, this point or that point, I don't know which point, okay? But that's what we need to find, such that the tangent line through that point, or the gradient, is half. I mean the slope of the tangent line, obviously. So, finding the derivative, we have y prime is equal to 6x, yeah, just 6x. Now, what does this mean? What does 6x actually mean? When you find the derivative, right, this gives you another function, right? Because y prime depends on x. Just like, for example, here, y depends on x, which is equal to 3x squared minus 2. Y prime depends on x, this is equal to 6x. That means the derivative, or the slope, changes, right? For every value of x, the slope changes, and this makes sense. In a parabola, the slope is variable, right? It's really steep here, it's horizontal here, and it goes really steep again, right? Oops, sorry. So the slope changes, obviously, and if we have a line, for example, y is equal to x plus 1, the derivative is 1, because guess what? The derivative is constant. Obviously, it's true, because the slope is always constant, right? It should make sense to you. Anyways, I'm going off topic now. We need to find a point such that the gradient is 0.5, right? So, we need to find this x such that the derivative is equal to 0.5, right? That means x is equal to 1 over 2 over 6. Now, for fractions like this, 1 over 2 over 6, for example, we have, this is 1 over 2 divided by 6, which is 1 over 2 times 1 over 6, that's 1 over 12, right? So just don't get confused. This is equal to 1 over 12. Now, did we finish? No, we found x, right? But they asked us for a point. Now, what does this x mean? It's the x coordinate of the point. So, we have this point P, right? It contains two numbers, the x and the y, right? We found the x, which is 1 over 12. The y, how do you find the y? Now, we know that this point lies on the curve, right? Such that we have, for example, I don't know, x is here, it's 1 over 12. Now the y is just what you substitute into this function, right? So y, in this case, is equal to 3 times 1 over 12 squared minus 2. Now, this is equal to 1 over 144 minus 2 is equal to 3 over 144 minus, let's see, this is 288 over 144. This is hectic, I know. Without a calculator though, okay, because they might not allow. This is equal to negative 285 over 144. I hope this is correct, doesn't look correct. Anyways, I'll check later. This is the y coordinate, therefore is negative 285 over 144. I think I can simplify, but I'll not. I'll leave it like this. So here's your point. And we're done with this question. Moving on, now we're in section 3.1.4, and the activities are number 2, 3, and 4. Activity 2, I think. Those questions are genuinely hard, alright? So this is, I think, the most important questions that you should know, and they're going to come in written, like I'm pretty sure. Anyways, for question 2, let's dissect this question. All right. Find the equations of the tangent and the normal to the curve, that curve, at the point where it cuts the y-axis. Now, what does it mean tangent and what does it mean normal? If you have a curve, right, the tangent line is, well, the line that intersects the curve at one point and looks like the slope of the curve at that point, which is, green here, is equal to the slope of a tangent, right? That's what a tangent is. Now the normal will be a line 90 degrees. It will be perpendicular to the tangent. That's not a nice line. That's not a line. That's fine. Okay, so it's perpendicular, right, to the tangent at that point. So how do we find normals and tangents? Well, we know that the slope of the tangent to a curve at a point is the derivative. And the normal, we can't get the slope. I'll teach you how. Anyways, so we have a curve. Let me write it down. We have y is, let's get the white color. Y is equal to x to the 4 minus 2x squared plus 1, right? Now, obviously, we need to find the derivative. So let's just do it. So y prime is equal to 4x cubed minus 4x squared. Let's get handwriting better, please. 4x cubed minus 4x. Yeah, that should be correct. So, here is your slope of the tangent, right? But we need to evaluate this derivative at one point, because remember, the derivative is a function that depends on x, right? So we need the x to be what? They said at the point where it cuts the y-axis. That means x is 0, right? So how do we do this? We set y prime and then we evaluate it at x equal to 0. That's how we write it, by the way. Is equal to, well, 4 times 0 cubed minus 4 times 0, that's just 0, right? So what does this mean? What is y prime at x equal to 0? This is the slope, which is m, of the tangent to the curve is equal to 0. And that's great, we're nearly done. For the tangent line, for any line, we need what? We need either 2 points or a slope and a point, right? Well, for the tangent line, we have the slope already. What's the point? They said at the point where it cuts the y-axis, x is 0. We know that. What's y though? So if we substitute x equal to 0, so y of 0 is equal to 0 minus 0 plus 1 is equal to 1. That means at x equal to 0, y is equal to 1, right? So we have our slope and we have our point being 0, 1. Apply the formula, we know this from grade 7, y minus y0 equals to m of the tangent in this case, x minus x0, so y minus y0 is this number right here. 1 is equal to, well, 0 times x minus x0, this is just 0. So y is equal to 1, right? Now what does it mean y is equal to 1? It's a horizontal line, right? Because this question is kind of long, we only did like half of it. I'm going to do the same thing with the normal, and then I'm going to graph this using an online calculator thing, and I'm going to show you what everything means, okay? So here is for the tangent. Now for the normal, so this is for the tangent, now for the normal, right? We already have most of the information. We have the derivative, we have the slope of the tangent. Now, remember we have this curve, right? This is the tangent. Now, the normal is this line. It's perpendicular. Now, what do you know about perpendicular lines? We know that the slope of the normal times the slope of the tangent is equal to -1, right? This means that if two lines are perpendicular, their slopes, the product of their slopes is -1. I'm not gonna prove it why, but just memorize it, alright? So that means the slope of the normal is equal to the negative reciprocal of the slope of the tangent. What do I mean by negative reciprocal? Well, you take the negative, right, and then you reciprocate it, right? So this part in red is for the negative and in blue is for the reciprocate. Anyways, that means the slope of the normal is equal to negative 1 over what's m of t? I mean, not m of t, this m sub t is 0, right? Now, problem, right? We have divided by 0, so what is it? It's infinity, right? Sorry. Slope of normal is equal to, well, infinity. Now, what does it mean? What do I mean by the slope is equal to infinity? We mean that this line is vertical, right? The slope approaches infinity. It's really, really steep. It's like a vertical line, right? So we deduce that the normal line is vertical. Sorry about the handwriting. I'm running really fast. Okay, anyways, now how do I find the equation of a vertical line, right? Now, in this case, it's a horizontal line, right? For the tangent, it's a horizontal line. We represent it as y is equal to some value. Now, for the vertical line, we represent it by x is equal to some value, right? Now, but x is equal to what? X is equal to, well, we know that the point cuts the y-axis. X is equal to 0. So, the equation of the normal line is simply this. X is equal to 0. It's a vertical line. It doesn't have any y in it because it's vertical. In this case, it doesn't have any x in it because it's horizontal, right? So this is for a vertical line, this is for a horizontal line. Anyways, this is the question and answer. I'm going to erase this and I'm going to show you a graph of this. Anyways guys, so I'm back with the graph of the function. Remember y is equal to x to the 4 minus 2x squared plus 1, right? This is the graph. It's fourth power, so we have this strange shape. Anyways, we have this point 0, 1. They said that the point cuts the y-axis, right? So x is equal to 0, that means y is equal to 1 by substituting x equals to 0 inside the equation. Anyways, what does the tangent line look like? Well, over here, the tangent line looks horizontal, right? It should be. This blue line is the tangent line at point x equal to 0. We can see its tangent because it intersects the curve at one point. I can like zoom in and it's really close to one point anyways. Of course it is one point, just the graph can't really show it by, some precision. Anyways, so that's the tangent line, right? What's the normal line? Well, since the tangent is horizontal, the normal is vertical, right? This is the normal line, the green line. It is perpendicular to the tangent line, cuts the curve at the same point, at 0, 1. Anyways, I just went way off topic, but the idea is there, okay? I'm going to do the same thing for 3 and 4. I'm going to solve it, and then I'm going to graph it in that calculator thing. Anyways, for question 3, we have find the coordinates of the points of intersection of the line y equals to a third x with the curve y equals to that. If these points are m, n, and p such that x sub m less than x sub n less than x sub p, show that the tangent to the curve at m and p are parallel and the tangent at n is perpendicular to them. Okay, this is a huge problem, alright? Split into parts A, B, and C. Now, how do we even start solving it? Let's read it again. Find the coordinates of the points. So we have several points, right? And we need to find the coordinates, right? Of the intersection of the line. So we have this line right here, the intersection of that line and this curve. So a curve can look, I don't know, like this, and then you can have a line, right? You can see that it intersects at some number of points, right? Of course, if we have some other curve, like, I don't know, that curve and that line, it will intersect in, well, let's count. We have 1, 2, 3, 4, 5, 6, 7, 8 points. But in our case, I don't know how many points yet, but it intersects anyways, right? We need to find those coordinates. Now, they said that if these points are M, N, and P, such that those points are arranged this way, right? Show those two things are true, right? Ignore B and C first. Let's find those points, right? Let me write y is equal to 1 over 3x. This is for the line. For the curve, we have y is equal to 1 minus x, x plus x squared. What is this notification? Anyways. Now what? This is in a really bad form. Let's distribute. So we have x plus x squared minus x squared minus x cubed. Yeah, I should be correct. Those x squares cancelled out is equal to x minus x cubed. Right? So this is y is equal to that. That's for the curve, and we have the line. Y is equal to x over 3. What do you mean by the intersection? They intersect at points, right? That means their x coordinates must be the same, their y coordinates must be the same, right? That means we set them equal to each other, right? So we set the y of the line is equal to y of the curve. That means x over 3 is equal to x minus x cubed, right? Now, first thing that we notice is we can factor out an x. So x over 3 is equal to x into 1 minus x squared. Now we make some observations, right? Because we need to find some x values, right? We notice that if we set x is equal to 0, we get, well, 0 equals to 0, which is true. That means that this is a solution. X equal to 0 is a solution, is one of the x coordinates, right? However, if x is not equal to 0, we can divide by x. Right? That's only if x is not equal to 0. Because we already ruled out this case, we put that on the side, we can divide by x. Anyways, 1 over 3 is equal to 1 minus x squared. Arranging this, we have x squared is equal to, let's see, we have 2 over 3. That means x is equal to plus or minus radical 2 over 3. Which is equal to plus or minus radical 2 over radical 3. Rationalize is equal to plus or minus radical 6 over 3. Sorry, over 3. Anyways, so we have 3 points, right? X is equal to 0, x is equal to negative radical 6 over 3, and x is equal to positive radical 6 over 3, right? So, we have those 3 x coordinates. Right? That means we need some points which they labeled for us M, N, and P. But there's a condition. We need that x sub m, so the x coordinate, let me get a red color, x coordinate of the m is less than x coordinate of the n, less than x coordinate of the p. Right? So, which x coordinate is the smallest? So we notice that, of course, the negative is the smallest, so x sub m is equal to negative radical 6 over 3, x sub n is equal to 0, x sub p is equal to positive radical 6 over 3. Arranging those x values in this way will satisfy this condition over here. That's not the final answer. We need the y values, right? Because they said the points. How do we find the y values? We substitute, right? Since we set them equal to each other, right? That means we're finding the intersections. That means we can substitute those values in either the line or the curve. Since they intersect at one point, right? Now, which one will we substitute it into? Will we substitute into this equation or this equation? Obviously, we do the line because it's simpler, right? So, in the first case, we have the point m is equal to negative radical 6 over 3. What's the y? If we substitute negative radical 6 over 3, we get negative radical 6 over 9. Right, so that is m. n, we have 0, substitute 0, we get 0, so n is 0, 0, and p is equal to positive radix 6 over 3. If we substitute, we get positive radix 6 over 9. Those are the 3 points, and we finished part A. Alright, and this is the hardest part. Part B and C, they're easier. Anyways, for part B, the tangent to the curve at M and P are parallel. We need to show that that's true. They said show that this is true and that is true. Part C for later. So the tangent to the curve at M and P are parallel. What does that mean? That means the slope of the tangent at M and P are equal, right? The slopes are equal, that means they're parallel. That means we're doing this point at M and at P. Now, how do we verify that they're parallel, right? Let's see. They set tangents to the curve, right? That means we need to find the derivative of the curve. That means, let's see, y prime for the curve is equal to 1 minus 3x squared, right? Since they said that they're parallel, that means y prime at M, the point M, is equal to y prime at point P, right? Let me write this better. Anyways, what does that mean? We have 1 minus 3. What's the x coordinate of M? We have negative radical 6 over 3 squared is equal to 1 minus, at P we have positive radical 6 over 3 squared times 3 in the beginning. Now, we need to verify that they're equal, right? So if those two values turn out to be equal, then we're good. So let's simplify. We have 1 minus 3. The negative cancels out, so we have 6 over 9 is equal to 1 over 3, 6 over 9. We can already see that they're equal. Doing some more simplification, we get, they're equal. So that means that we verified that the slope of the tangents to the curve at the points M and P are equal, or the tangents are parallel at those 2 points. Anyways, so that's part B done. I told you it's simple. And the tangent at N is perpendicular to them. So, remember in the last video, I think the last video or the last exercise, I told you that the slope of the normal times the slope of the tangent is equal to -1, right? What's the slope of the tangent? Well, we know that the tangent to the curve at M and P, so the slope of the tangent is simply the slopes that we found here. This is the slope of the tangent, right? So if we simplify that, let me do that actually. 1 minus, so 6 over 3 is 1 minus 2 is equal to -1. Alright, so the slope of the tangent is -1. We need to verify that the tangent at N is perpendicular to them. Right? So instead of saying the m of the normal, which is not the case, let's just say it's the slope at point N, not normal. Same thing. Anyways, so the slope at N times slope of tangent, which is -1, is equal to -1. Right? So slope of the normal should be 1. Now we need to verify this. Right? So what do? We substitute. Again, substitute this x value, 0, into the derivative of the curve. How do we do that? We set y prime, set x is equal to 0, is equal to 1 minus 3, 0 squared is equal to 1. So we just verified that the slope of the tangent to the curve at point N is equal to -1, which satisfies this. Okay, now I'm going to show you the graphs. Alright guys, so I have this ready and set up. So the red curve is the curve, right? And then the blue line is, well, the line. And as you can see, they intersect at 3 points, just as we predicted, the M, N, and P, right? So we have point M, point N, and point P. This is, of course, estimated. We have negative 0.8 here. It's actually negative radical 6 over 3. Anyways, so what did we do exactly? Yeah, in part A, we found those 3 points, right? And in part B, we showed that the tangent at this is the tangent to the curve. Sorry, let me just get this out of the way. This is the tangent to the curve at point M, right? We showed that is parallel to the green line. So we can see graphically that the blue line is indeed parallel to the green line, right? And then we showed that this line, the tangent at point N, is perpendicular to so the purple line is perpendicular to the blue and green line, right? And it gets pretty messy here, but the idea is, I think, clear. Anyways, those are really long questions, okay? So I'm going to end this video here, so part 2 will end here. Part 3, we'll do question 4, and we'll move on to some more activities and workbooks. Anyways, guys, if you understood question 2 and 3, good job. If you didn't, then again, Saturday we have a session in the video conference room from 11 to 1. Ask us questions there. All right. See you in part 3.